So hello guys and welcome to my channel. Today again I am back with another important numericals on machine design. So here you can see a numerical on the screens. A 75 kilowatt 3000 volt 8 pole 50 hertz and 3 phase star connected slip ring induction motor has the following data. Here a stator bore is given as 0.66 meter, a stator core length is given as 0.30 meters, and the number of stator slot is given as 96. Number of rotor slot given as 72, and number of stator turn per phase is 286. And total specific permeance due to a stator slot 4.9 mu and no load current per phase is given as here 6.1 ampere. Now and no load power factor is given as 0.095 and harmonic leakage reactance per phase is also given and which is 0.9 ohm. And here in this numerical we have to estimate the total standstill leakage reactance of a motor referred to stators and the winding employs full pitch coils. So here in this question we have to determine the total standstill leakage reactance of the motor shaft referred to stators. So first, the stator slot per pole per phase is given as 96 upon 3 into 8, and here we can see a stator slot per pole per phase. Here you have 96, number of stator slots 96, and for a stator slot per pole per phase, so 3 phase and per pole is 8 poles, so 96 upon 3 into 8, that is going to give 4. Similarly, rotor slot per pole per phase is rotor slot is given as 72, so 72 upon 3 into 8, that is going to give 3. Now here, in order to calculate the slot leakage reactance, here xs we have the formula as 8 pi f ts square l lambda ss upon pqs. So 8 pi f into ts, and here the total ton is 286 ton given. Here you can see the number of stator ton per phase is 286 given in the questions. So TS equal to 286 square into L, value of L in 0.5 and lambda SS. So lambda SS is 4.9 mu given in the question. So 4.9 in place of mu you have 4 pi into 10 to the minus 7 upon PQ. Value of P is 8 and QS is 4 here. We have used this value QS. So we'll get 9.9 ohm. Now power factor is given as cos phi equal to 0.095, so sin phi can be calculated as 0.995 or means root under 1 minus cos square phi, and it is going to give the value of sin phi. And Im is equals to IE sin phi naught, so IE is given as 6.1 into sin phi naught, and sin phi naught you have used this value, and in place of IE you have 6.1. Here we have used no load current I naught means 6.1 ampere, this value. So Im is equals to 6.007 ampere. Now a stator voltage per phase ES will be 3000 upon root 3, so 1732 volt, and magnetizing reactance XM will be ES upon IM. So we have obtained the value of ES means 1732 and IM is 6.07. So the XM will be 285.33 ohms. Now zigzag leakage reactance will be XZ will be 5 upon 6 xm upon ms square and 1 upon qs square plus 1 upon qr square. So 5 upon 6 xm we have obtained we have obtained the value of xm, and ms is equal to 3 phase, so a 3 square 1 upon qs and qr. We have obtained the qs and qr in the first step. Here we have qs and here we have qr. So QS and QR taken from here. Now on substituting all the values, we will get the value of zigzag leakage reactance as 4.58 ohms. Now pole piece is given as tau is equals to pi d upon p, so pi into d, and d is the here stator bore diameter, and that is 0.66 given, and pole is 8. So on further simplification we will get here 0.86 meter here, and a stator slot piece YSS is given as pi d upon ss, so pi into d is 0.66 and stator slot is given as 96, so 0.0216 meter. And now we have the relation here. We have the relation as L naught lambda naught equal to mu naught ks tau square upon pi YSS. So mu naught into, in place of ks we will use 1 and in place of tau we will use this value 0.26, and pi into ISS, and we have calculated the value of ISS here. So L naught lambda naught is going to give 0.987 mu naught, and here over angle leakage reactance. So over angle leakage reactance is given as 8 pi f ts square L naught lambda naught by upon PQS, and in place of here right now here L naught and lambda naught. So we'll use this value. Here we have obtained the value of L naught lambda naught. So it will be 0.987 mu naught. So 8 pi f in place of f 50, and in place of ts we have 286 square into lambda naught and L naught lambda naught. So it will be 0.987 mu naught, this value, and upon PQS. So P is 8 and QS is 4. So we'll get here 3.98 ohm. So the total leakage reactance will be XS plus XZ plus X0 plus XS, and here the value of XS means the harmonic leakage reactance, and it is given in the questions, and that is given as 0.9 years. So if you add all the value of XS plus XZ plus X0, we will get the total leakage reactance, and the total reactance right now will be 19.36 ohms. And now here we have given the next one, 11 kilowatt 3 phase 6 pole 50 hertz 220 volt a star connected induction motor has 54 stator slot. 54 stator slot is given and is containing 9 conductor. Calculate the value of bar and in ring current, and the number of rotor bar is 64, and the machine has an efficiency of 0.86 and power factor given as 0.85, and the rotor MMF may be assumed as 85% of the stator MMF. So here first we need to calculate the IS. So IS is equals to, here we have given 11 kilovolt, here 11 kilowatt given, so P upon root 3 into VS into power factor into this efficiency given as 0.86. So 11 into 10 power 3 upon root 3 into 222 into 0.86 into 0.85, and this is going to give 40 amperes. And sometimes in such type of numerical problems the value of IS is already given in the question, so no need to calculate the value of IS. Now number of stator conductor will be 54 into 9 means 54 into 9, that is going to be 486. Here you can see in the questions 54 stator slot and is containing 9 conductors, so 54 into 9, and that is going to give 486. So number of stator conductor 486 and a stator turn per phase, so TS will be 486 upon per phase upon 6, and here the value of pole is given 6. So 486 upon 6, that is going to give the stator turn per phase, and so it will be 81. And now stator MMF will be 3 IS into TS. So 3 IS, we have obtained the value of IS, and also we have obtained the value of TS here. So on simplification we will get the stator MMF as 9720 amperes, and here in the last part you can see in the questions the rotor MMF may be assumed as 85% of the stator MMF. It means rotor MMF will be 0.85 into this value, means stator MMF 9720. So 0.85 into 9720, and the rotor MMF will be here 8250. Now rotor MMF will be 8250. Here we have obtained the value of rotor MMF as 8250. So rotor MMF is 8250, and the formula for rotor MMF is SR into IB upon 2. So SR is 64 into IB equals to 8250 into 2. So you'll get the value of IB, means here value of IB will get. So value of IB is the bar current, and in ring current I is equals to SR into IB upon pi into P. So SR is 64 into IB is 258, we have obtained here, upon pi into P is 6. So you'll get it 883 amperes as in ring current. Now area of each bar AB, so AB will be IB upon del, we have obtained IB, and the del is 5 ampere per mm square given current density in the questions, so 51.6 mm square, and area of each ring will be I upon del, so I is 883 upon 5, it is going to be 176 mm square. So in this way you can calculate such type of numerical problems. Hope you enjoy the lectures. Thanks for watching and please don't forget to subscribe to my channel. Thank you.